What happens when you think you've found the digital smoking gun, but can't prove it's authentic? In digital forensics, it's not just about finding evidence. It's about proving that the evidence hasn't been altered. In Chapter 9, we go beyond discovery into the deep validation of digital evidence, and it's a must-know skill if you're planning a career in cyber investigations or legal tech. If you find this content valuable, smash that like button, subscribe to stay ahead in digital forensics, and share with your tech-savvy crew. Let's make this knowledge go viral for the right reasons. We start by looking at how to decide what data to analyze. This varies based on whether you're in a criminal case with a search warrant or a civil case governed by discovery orders. The scope of an investigation matters a lot. If you're not careful, you'll encounter what we call scope creep. That's when an investigation spirals beyond its original boundaries, chewing up time and resources and potentially jeopardizing the integrity of your work. Let's talk about case planning. Whether you're dealing with an employee suspected of espionage or investigating cyber harassment, every investigation must be purpose-driven. Everything must be documented. You're not just finding evidence, you're building a story that can hold up in court or under corporate scrutiny. One of the most important tools introduced in this chapter is Autopsy, a robust digital forensics platform. It supports analysis across multiple file systems like FAT, NTFS, X4, and HFS+, and it allows you to import the National Software Reference Library to validate known files. Using Autopsy, you can collect hash values, which are like digital fingerprints for your data. This is where validation becomes essential. Think of it like DNA testing for files. If a hash doesn't match, your evidence might be compromised. It's important not to rely solely on one tool. Tools like WinHex and AccessData's known file filter provide granular control, allowing for hashing of individual sectors, performing blockwise hashing, and filtering out known good or bad files from your dataset. Now let's explore how data can be hidden or encrypted, because yes, people really do try to cover their tracks. Some methods are as simple as changing file extensions to disguise file types or hiding entire partitions using built-in disk utilities. Others get more technical, such as using bit shifting techniques to obscure readable code, or encrypting files with tools like PGP or BestCrypt. And then there's steganography, where data is hidden inside other files, often images or videos, in a way that isn't immediately visible. Detecting these methods involves analyzing file attributes, scanning for unusual partition maps, and inspecting file headers and slack space. It's detailed work, but essential to building a reliable evidence base. Encrypted files and password-protected systems present another challenge. For this, you'll need specialized tools like John the Ripper, OpCrack, or AccessData's PRTK. These tools use brute force or dictionary attacks to crack passwords, and some leverage rainbow tables for efficiency. In more advanced systems, password hashes might be salted to make them more resistant to these techniques. When it comes to steganalysis, the process of detecting hidden data, this chapter introduces different attack models. For instance, stego-only attacks work with just the suspected file, while known cover attacks compare the original and modified files. Each method has its strengths and requires a sharp eye and the right tools. To make this real, try creating a test file and encrypting it. Hash it, change its extension, and then use your forensic tools to analyze what's changed and what can still be recovered. Practice cracking a password in a controlled lab environment. This kind of hands-on experience is what transforms you from a student into a professional. At the heart of this chapter is the principle of credibility. As a digital forensic examiner, your reputation and the outcome of your case rest on your ability to validate and defend the integrity of your evidence. Without proper validation, even the most compelling evidence can be dismissed. If this episode helped clarify these critical concepts, do me a favor, like the video, subscribe for the full course, and drop a comment sharing the most surprising validation or data hiding technique you've encountered, or hope to explore further. What method of digital evidence validation do you think is most critical in real-world investigations, and why? Coming up next, we'll explore Chapter 10, Virtual Machine Forensics, Live Acquisitions, and Network Forensics. Stay tuned and stay forensic.